Good morning, good afternoon, and good evening. This is another preview of the NEO Persistable Classes platform, and specifically an NEP5 token template that was created with the platform. So a couple shoutouts to start things off. The ability to rapidly develop C# smart contracts on the NEO platform. A lot has to be said for the NEO Debugger and the ability to use that in this rapid cycle kind of edit, compile, debug mode. And so a shout out to Sergio, who's on a weekly basis supporting the NEO Debugger with features that people want, changes in the underlying VM. It's a lot of work, and I really appreciate what he does. The second thing is this NPC NEP5 template was inspired by David, who has recently been publishing a C# NEO NEP5 development tutorial series on YouTube. And so I encourage you to go and check out his channel. He's got 3 videos there, and I think he's working on a 4th and a 5th one. Very well paced. They're about 20 minutes a piece, 20-25 minutes a piece. Really a good resource. So the purpose and goals of this webcast is to walk through and demo the Persistable Classes reference implementation of an NEP5 token smart contract. It implements all the required operations and not the optional operations, and it uses 2 entities, NEP5Base and NEP5LedgerEntry, and I'll go into those in a little more depth. In terms of new NPC features to be highlighted, concept of using multiple features and what that looks like. The layered functionality. The base only requires very basic functionality as a managed entity. It doesn't need to be persisted, so we'll see how to do that. The ledger is the persisted component of an NEP5 token, and so that needs the level 3 persistable storage. So we'll see the layered functionality. We're going to be walking through the code. I'm not going to build this one from the bottom up. You saw that in the previous video, the previous preview, but we'll look a little bit at the logging and tracing capabilities that the NPC platform supports, and then start to introduce the concept of reusable entities. So the ability to define a simple model class and being able to attach a few functions to it, and have that be a reusable entity that then can be used across projects, across distributed applications in an easy way. Of course, we're going to do a live demonstration. I learned a lot about performance and cost related to NEO C# smart contracts. I'm going to cover that in a second video. Again, this is an awareness video. It's not an education or training session. With this video and the previous one, you may be able to develop an NPC smart contract, but that's not a specific goal. The principles and the drivers. So as usual, being able to provide reliable information, and that means 4 specific things to me: timely, accurate, visual, and complete. To use as little time of your time as possible, and by corollary, not waste any time, or waste as little time of yours as possible. The driver being, again, helping enterprise developers come up to speed quickly on the NEO platform, and to make it as easy as possible to develop enterprise class distributed applications. So Some of these will eventually get into more depth, but this is, again, focused on innovators and early adopters. People are willing to take risks, willing to accept a few extra steps in the process. And the goal of this webcast is really at the awareness level, making you aware, providing very basic information about the NPC NEP5 token reference implementation on the NEO platform. So just the last slide before the demonstration, talking about the layered functionality. So you want to be able to minimize the amount of code in your smart contract, generally keep them small. And so NPC has been specifically designed to be additive in a layered sort of way. So level 0 just gives you the basic class definition with the methods, or excuse me, with no methods and just the fields. Level 1 turns that basic entity into a managed entity. So you're able to create new instances, you're able to pass initialization parameters like a constructor in C#, except we don't have constructors that work effectively. Being able to return a null entity, or create a null entity, ask if that entity is null, so that's often useful in tests or looping scenarios. The ability to set the properties or fields of an entity, so we have set, which allows you to set all of the fields for the stated entity, and then we also have setters and getters for each of the individual fields, and there's a separate getter and setter for those. Finally, there's a log function specific to this class where you can provide a label and then a variable representing your entity, and it knows how to dump basically each of the fields of the entity into the NEO event log. So that's level 1 managed, and that's strictly additive and optional to level 0 basic. Similarly, level 2 persistable adds these following 6 methods. When you go to retrieve an entity from the NEO storage, you use get, and it supports the 2 classic data types, strings and keys. You have also the ability to put an entity, and you provide the key. So very easy to use, and it knows behind the scenes how to serialize all the fields and put them onto the blockchain. When you retrieve an entity with a given key, and that key doesn't exist, or an entity with that key doesn't exist, it'll return a missing entity. And so you have the ability to ask, is an entity missing? And we'll see some examples of that as we walk through the code. There's other levels. Level 3 collectible gets very interesting because that allows you to manage arrays or collections of objects, either index collections indexed by integers or arbitrary collections with named indices, I guess is the best way to describe those. That'll be a subject for another talk. So let's get into the demo and the walkthrough. So go over here to Visual Studio. So here's a Visual Studio project for the NPC NEP5 token reference implementation. It follows the pattern of there being a model project that has the model classes in it. And then it also has a contract project where your actual smart contract lives. So let's look at the model classes. Now, in the introduction, I highlighted that there's the NEP5 and LedgerEntry. There's a couple others here that were defined, but I subsequently took them out of the implementation. But as reusable classes, I'm keeping them here to be used in other scenarios. I'll explain more in part 2 when we talk about performance, why I didn't use the NPC environment entity and why I didn't use the funding round. So let's look at base. So the base is what are the minimal parameters required to define a token. It needs a name, a symbol, the number of decimals represented by a fractional token, and the total supply. And so simply by creating an instance of the base, you create an instance of an NEP5 token. It's pretty simple. We'll see that as we go through. And the base, as you can see, just uses the basic and the managed. So this is really just saying that we want getters and setters for all of these objects. These are essentially constants for any given token. These will be constants. So we don't want to persist these, or we don't need to persist these to the blockchain. They'll just be constants in our program. Ledger is the on-chain portion of an NEP token. And I've configured it to look like a ledger. So there's a timestamp, the debit or credit amount, and the balance. So if you think of your checkbook, 3 columns in your checkbook, timestamp on the left, often you'll have a description, item description in the middle, and then the debit and credit amount, whether it's plus 100 or minus 100, and then the running balance is kept here. So I don't maintain a running ledger. That's part of the roadmap. That's part of another level beyond persistable and collectible. The ability to do what I call historization. But for now, there will be a ledger for every account that's involved with this token. So initially, when the token is deployed, there'll be a ledger entry for the owner account. And then as tokens are distributed to other accounts, there'll be subsequent ledger entries created. You notice here that there's, in addition to the ledgerentry.cs file, there's ledgerentry L2 custom fields.cs and ledgerentry L2 custom methods.csi. So in addition to the methods I showed you before that are formally part of the NPC platform, you're obviously going to want to create additional methods, and you'd like to be able to share those. So as part of the development process, you can create just a prototype. So one of the methods I created here is update ledger. Subsequently, I didn't use this method, but this is still a valid example. And this is defined this way just as a skeleton because you want this model to always be compilable. So let's do rebuild, and it'll always compile. Again, these are just plain old C# framework classes. But as you progress through the implementation of your contract and you fill out that implementation, you can copy that implementation back into your model. So this is the full implementation of that initialize method, and the way the compiler works is you decorate a partial class to say that this has, in this case, level 2 custom methods, meaning it only needs the level 2 capabilities of the underlying platform. And what the compiler will do is automatically copy this and correct the namespaces and what have you into the contract. And it will also, if you have a CSI, an actual implementation, it'll then replace that with an actual implementation, and again, manage all the namespaces and everything for you. So so I've rebuilt this once, and then we just, as usual, will run the use debug to run the NPC compiler. And the NPC compiler then is going to read this model project and create all the necessary classes in the contract project. So let's run that. So we see that, and it's read the environment, which we haven't looked at really. It has some custom methods. The compiler is smart. It's not going to overwrite all that custom code you just wrote for yourself. So we see here there's a warning that a custom implementation already exists, so this step was skipped. Here's the ledger. The ledger, again, has some custom functions, and those are already been, once you run this once, basically, the second time you run it, it won't overwrite those. And then down here we have funding round, which we're not using, and then base. And base only needs level 0 and level 1. We said the ledger needs to be persisted, so we've decorated that to support all 3 levels. Okay, so let's close that up, and we can see that here's the implementation, for example, of the base, and it's basically a copy of the model contract. The methods have been made private, underscores have been put in front, and the first letter has been changed to lowercase. So that standardizes the naming, so that, for example, in the level 1 managed functions, they use use all of those names. So, for example, here is the set function, and it's setting all of those entities to whatever names are being passed in. So that's the one class we're going to use, and then we're also going to use ledger. So if we look at level 0 for ledger, it's just the fields that you defined in your model class, tweaked a little bit here, changed to private, that sort of thing. And then we have the level 1 implementation, which it makes it a managed class, the setters and the getters, the support for creating new entities and null entities, for checking if something is null, and then for logging. If we look at the level 2 NPC methods, it goes a little bit higher in terms of the functionality provided. There we can see the put method that takes a ledger entry and a key, a byte key, and does the right thing, just a series of puts, one for each element of the class. If we go down to get, again, there's get for the byte key and there's get for the string key. They're almost identical. Again, it just does a series of gets for each member of the class, each field in the class. Might have to do some fancy coercion, and then it rebuilds the entity. So that's a quick tour of the code that was automatically generated. Let's focus now on the contract itself. So that's here, and this is a NEO contract project created with the Visual Studio extension. And so here we have the standard main for an NEP5 contract. Here's where we create an instance of NEP5Base. So we put in the name of the token, the symbol, the number of decimals, and the total number of tokens. So this is the heart, if you will, of the token. This is what distinguishes one token from another at the minimum viable token perspective. We use the log, the NEP5 log method to log that out to the event log. I tend to put a lot of tracing in, but I control it with the NEO trace object here. You might be able to see in the recording that this is actually grayed out a little bit. These are actually Boolean values, static Boolean values. And here's how you can control what actually what output comes out at any given time. All of the runtime methods have 1 or 2 trace methods in it, so you can get a lot of verbose tracing of what's going on. The advantage of using these constant Boolean fields is these get compiled out completely if they're set to false. That's why you see it's currently grayed out. And in fact, what I usually do, and what I will do for this, is I'll maybe turn on the verbose and the testing. Trace is one thing that gets overwritten whenever you rebuild, and that kind of that's okay. That's kind of what makes sense. Okay, so then we want to process the operation. So we pass in the operation and the args along with the token base. And this we'll look at immediately. And then we get a result back, which we write out to the event log, and we return it as the object. So that's your main. Process operation has the same logic that you'd normally expect. We check, if it's deploy. I also have a very simple ping thing that just returns a string called pong for doing very, very basic testing, like is the smart contract there? And then these are all the standard required NEP5 methods. So name, symbol, decimals, total supply. The NEP5 specification as it's currently written is a little bit vague. It actually states that you need to have certain public methods even though they're not used. So I've conformed to that as strongly as I can. So there is a name method that's public static. Mine takes a token base as an operation, and what it does is it uses a token base get name accessor to retrieve the name of the token out of the token base entity. And so if we were to look at that, it's just returning name. So it's just like an accessor in regular C#. Cool. So we go back up here. Name, symbol, decimals, total supply are all simple, just like I showed you, because they're just returning a field out of token base. Balance of gets the account as this first argument. I've got a little bit of code in here that says just makes it easy when I'm running it in the debugger. If I give it an account of 0, it's automatically going to sub in the owner account script hatch, which is hard coded in the usual way up here at the top. And this is also tied into the NEO trace flag, so this will automatically be commented out if you ever ship this as a production application. So result equals balance of account. So balance of, we'll quickly look at that. So balance of needs to understand the current balance of the account. And as I said before, the design here is that there's a ledger entry for every account. So what we need to do is do a get, and we're using the account name or the account byte array, the account script hash as the key. So we can get that. We get a ledger account entry back. We can log that ledger account entry. We can check to see if it's missing. Remember, part of the level 2 persistable is that we support the concept of missing entities if the key doesn't exist on the blockchain. So if it's missing, what we're going to do, if it's not missing, what we're going to do is get the balance out of the account ledger entry. If it is missing, we're just going to return a balance of 0. So it's a little bit of side effect programming here. I noticed that in other implementations of NEP5, if nothing's there, they just return that 0, which is, I guess, okay. If we go down to one of the other methods, I guess the only other mandatory method is transfer. So transfer needs 3 arguments, and I've just basically copied this right out of the ICO template. So from is 0, 2 is 1, the amount comes out of arg2. I've got a little bit of stuff again to help me that if from is set to 0, I use the script hash for debugging, and then I do the transfer. When I go to transfer, again, one of the cool things here is not only kind of the ease at which you can code this, but kind of the lingo that you start to use. So This comes out of the ICO template, but rather than having all these returns in the middle of my code, which is not a style I prefer, I've refactored this a bit. So if the amount is greater than 0, let's go ahead and do the transaction if we can. If from equals 2, you're trying to send to yourself, just simply return true. That's the semantics out of the ICO template. So if the amount is greater than 0 and from is not equal to 2, we go down here. We do a little bit of tracing. The first thing we do is want to get the from ledger entry. So we say ledger entry get passing in from. So we get that ledger entry and we can log that. We get the from balance by calling get balance on the from ledger entry. If the from balance is greater or equal to the amount. Skip out this commented stuff. I'll talk about that in part 2 about performance. What I want to do is, if the balance is greater or equal to the amount, I then want to update the from ledger entry, and I'm setting it to 0 minus the amount, so that's the debit credit amount, and then I also want to decrement the amount from the current balance. So this is rewriting the ledger entry for the current account, and the rewriting actually happens here in the put that immediately follows. This notation may look a little weird. That's because the NEO compiler, if I had just minus amount, it wants to do a unary minus, and it won't do that. So I had to fool the compiler by putting 0 minus amount and turning that into an expression. If we go down here, once I've updated the from ledger entry, I need to update the to ledger entry. So I get the to ledger entry just by saying get that entry. And then I get the balance from that entry. And then I update the ledger entry with 0 plus amount. I guess I didn't have to do that. I was just being anal. And then I do to balance, plus the amount. And then finally, I just ask the ledger entry to put itself back at the to address. Log it, and then I do the transfer event as per the specification. So this is really the heart. And I guess one of the things I like is it's easy to read. You're starting to talk in business terms. If I was to do a little architecture diagram, I could show the ledger base living in the smart contract as constants, as universal truths, never to be changed, and then I could show the ledger entry as an object down in the living on the blockchain. And if I go and look at again that ledger entry, it's composed of those three things. Not to give too much away in part 2, but I came in just a little bit over the 10 gas when I had some of these other classes in play. And so I ended up having to set the timestamp to 0. I chose to do that for this webcast because I wanted to be able to talk and show and measure the performance and execution cost of these other scenarios. But this does run in under 10 gas reliably. So I guess we should see that working. So I'm just going to go up here and delete this. This will make sure that I delete the debugger state more than anything else. So I'm going to do start. So I'm in release build because this shows you the fastest performance. Let's do it because we're here, and then we can go back and do the other one. Main, because this is a brand new deployment, because I deleted the debugger state, what I want to do is change this to deploy. and it doesn't matter what the arguments are. So that runs like you'd expect in about 5 gas. And if we go down here, we can see that's the token base object being dumped out. I dump out the operation. You can see deploy being entered. That the owner's ledger entry was missing, so we created a new one, and then we returned true. While we're here, I can go and say, okay, let's now do a transfer. And we're going to go from script hash 0, which is part of that debugging code that I put in there. So this will substitute the owner for 0, and I'm going to use a script hash of 1. Again, just to make it easy for debugging, and I'm going to transfer 100 of my tokens. So if I go debug, we can see here it's just a little bit over 10. That's fine. We'll get underneath in a minute. There's the token base, the transfer. Just a reminder that I've got that debugging code on, and that I'm using a false or faked up owner hash. The amount's greater than 0. It's from is not equal. So we read in the from ledger, the one that was initialized. We've subtracted. That's the debit credit amount that's in the ledger entry. There's the balance in the ledger entry, and the time stamp for the ledger entry I'm not updating. And then here we see the to ledger being created brand new, and it now has a debit credit amount of plus 100 and a balance of 100. And we see the transfer method being executed, the transfer event being executed, and the true being returned. So if we want to get this underneath 10 gas, which is always important, we go in here and we can just change all of these. From true to false. Testing I'm going to leave true, because that's the one that leaves the little bit of that testing debugging code in there. So now if I run it again and I do F5, bingo, we're underneath 10, which is good. Just to finish this off, I could go back into debug mode. One little thing is that when you change between debug and release, you need to make sure that you update these properties, because as you go from debug configuration to release configuration, these are actually different sets of parameters for the rapid edit compile debug cycle. So now when we run this, we're in release, we've got all the debugging turned off, and we go debug and we're underneath, so that's good. And all we get is the transfer message out. One last test, we'll do debug. And this is debug with things off, so this is kind of in the middle. I'm kind of giving away my part 2, but we got lots to talk about there anyway. So here I'm going to do a transfer. Oh, the other thing is, when you switch from release to debug, you're also you're losing the debugger state. That means we have to reinitialize the debugger state when we change from release to debug. So what I have to do here is not debug but deploy. And that does it fine. And then we're going to do transfer. We'll talk more about performance and execution cost analysis in part 2 of this webcast. So to wrap up, here's a bit of a architecture diagram for the reference implementation of the NPC NEP5 token. So on the left here, again, that's the model class that we used to define the NEP5Base, and that was allowed us to realize the NEP5 base object, the token base object in our smart contract with the name, symbol, decimals, and total supply. Those are constants, so we just used level 0 and level 1 managed entities for that. Over here on the right is the ledger entry object that had the timestamp, the debit credit amount, and the balance in our model class. We needed to persist that into the blockchain, so it uses level 0, level 1, and level 2. And we can see how that's manifest itself, in our smart contract code. And then down here, we see how that's realized on the blockchain. And so the act of calling get on a ledger object, ledger entry object, is to read the physical representation of that object, of that entity, and use it to realize an in-memory version of that. So I think more and more, as smart contracts get more sophisticated, the decomposition of business objects into small entities, smaller entities, is going to be important. And the concept of normalization will become even more important, data normalization. This is kind of an early example of that. So in terms of resources, again, I refer you to Dave's excellent tutorial series on YouTube. Again, that edit, compile, debug cycle that I kind of dwell on a little bit, when it's that fast, it opens up so many more opportunities for exploring, like performance and cost, than, for example, if you're using NEO GUI. These are the 4 projects, again, that are supporting what I demonstrated today. There's the NPC compiler, NPCC, that's part of the Persistable Classes Platform 2.0. You'll find references to those on the NEO Blockchain C# Developer Center of Excellence, and all of this content will eventually become part of the Quick Start Guide. So the same thing, tokenize every little thing. You got to be careful about what the things are. You have to start thinking about normalization. You got to start thinking about larger things being composed of very small objects on the blockchain. Again, you can find me and many other experts in the C# channel on the Discord group, the NEO Discord group. You can connect with me on LinkedIn, and my email address is neotoronto@outlook.com. Thank you for watching.